Hi everybody, my name is Alexandra Davison, and for discussion number 10, I will be discussing how to find the Taylor polynomial approximation for x, y near 0, 0 of the function z equals sine 2x plus y plus cos of x plus y squared. The first thing that we want to do with any Taylor polynomial approximation is find the partial derivatives. Here we go. So we have the first one we're going to work on is f of x, y. That is going to equal, well, we have sine 2x plus y, and we're looking at the partial derivative of x. So 2x, the derivative of 2x is going to be 2. So 2, what is the derivative of sine? Sine is going to be cos. 2x cos plus 2x plus y. Now we're going to use the same method to find what cos x plus y squared is. Well, the derivative of x is 1, and the derivative of cos is negative sine. So we're going to do negative sine x plus y squared. Okay. I am just going to change this a bit. Sorry. And there we go. Okay. Just wanted to make it clearer. So the next one we're going to do is going to take the partial derivative of the original function of y. So this is the original function, and we're just going to take f of y. So f of y of x, y equals sine 2x plus y. Derivative of y is 1. So it's going to be cos 2x plus y. Same thing for cos x plus y squared. The derivative of y squared is 2y, so we're going to have minus 2y times sine x plus y squared. Okay. Now, the next function we're going to look for is f of x, xy. So we are going to take the partial derivative of x of this function, f of x. So that is going to be partial derivative of 2x again is 2. 2 times 2 is 4. But this time, because it is cos, it's going to be sine, negative sine, 2x plus y. Same thing on the other side, minus cos x plus y squared. Okay. Moving on, we're going to do f of y, x of y. So we are going to take the partial derivative of y of f of y, which is this function right here. So that is going to equal, cos is again negative sine, the derivative of y is 1, so 2x plus y, and derivative of y is the derivative of y squared is 2y. 2y times 2y is going to be 4y squared, and sine is going to be cos, so negative 4y squared cos x plus y squared. Okay. So now that we have the 4 ones that we need, oh, I'm sorry, my apologies. We still need f of x, y. Okay, so this is, we're taking the partial derivative of y of f of x. Okay. That is going to be, so we have 2 cos 2x plus y. So the derivative for y is 1. So we're going to have negative 2 sine 2x plus y minus, and we're going to do the derivative of y, which is 2y, and sine is cos. So 2y cos x plus y squared. Okay. Now, the next move that we are going to do is see what f of 0, 0 is for f of x, fy, fxx, fyy, fxy. Okay, I'm just going to bring this over a bit. So, what is f of 0, 0? And when I keep saying f, I do mean x. I mean z, I'm sorry, meaning z. So that is going to be sine 2 times 0 plus 0. So sine 0, everyone knows what sine 0 is, 0, and cos of 0 plus 0 squared. So cos of 0 is going to be 1 equals 1. Okay. And then we're going to do f of x of 0, 0 equals 2 cos times 2 cos 0 minus sine of 0 is going to be 2 cos of 0 is 2 times 1. 2 times 1 minus 0 equals 2. Okay. For f of y of 0, 0, we have cos 0, which is 1, minus 2 times y, which is 0, times sine of 0, which is 0. And that equals 1. Okay, I'm just going to make this a bit lowercase to fit. Okay, there we go. Okay, now we're going to do the same thing for the rest. So f of xx of 0, 0. So negative 4 sine times 0 is going to be 0, minus cos of 0 is going to be 1. So 0 minus 1, which equals negative 1. Okay. For f of xy of 0, 0, so f of, f of y of 0, 0. So negative sine times 0 is going to be 0, minus 4 times 0 square, which is 0, times cos 0, which is 1, equals 0. Okay. And then we have the last one, f of xy of 0, 0 equals negative 2 times 0 minus 2 times 0 times 1, which equals ultimately 0. Just going to make that a little low. Okay. Next is we are going to be using the formulas. So f fxy is approximately equal to lxy, which equals f of 0, 0 plus f of x 0, 0, x minus 0 because of the point we are looking at, and f of y, 0, 0, y of 0. So using from what we know from above over here, we're going to be needing this one first, and this one, and this one. So it's going to equal f of 0, 0 is 1, f of x of 0, 0 is 2 times x minus 0, plus f of y is 1, y minus 0, which ultimately equals 1 plus 2x plus y. Okay, and last but not least, we're going to do f of x, y, which approximately equals q of xy, which equals L xy plus f of xx of 0, 0 all over 2 and times in the whole thing by x minus 0 squared. And that is going to be plus f of xy of 0, 0, x minus 0, y minus 0, plus f y of 0, 0 over 2 times, divided by 2 times y minus 0 squared. Okay, and using what we know, Lx was 1 plus 2x plus y. F of xx is negative 1, so then we're going to have negative plus negative 0.5, which is 1/2 x squared, because if we FOIL out x minus 0, it's going to be x squared. I mean, x minus 0 squared, we're going to get x squared. F of xy is 0, so that's going to be plus 0. So there's going to be no xy. And then f of yy is, again, 0, so that's going to be 0. 0 divided by 2 times y minus 0 is going to be 0. So for qxy, the equation is going to be 1 plus 2x plus y minus 1/2 x squared. So the answers are right here for the approximations. I hope this helps.